Okay, so we are doing identifying and graphing linear equations. Okay, so the only type of linear equations we're doing today, though, are these. Do you remember what this is called? So this is our linear standard form. Our curriculum calls it the linear equation in two variables just because you have the two variables on one side. But it's just linear standard form, which is how we know it. And what I'll call it. So it's ax plus by equals c. All that's telling you, a, b, and c are numbers. So like, yes, this is the formula, so it's lots of letters, but it's normally going to look something like this. Okay? Where x and y are your only letters. Yes? So it's just standard form, your x and y are on the same side. So knowing that it says a, b, and c are real numbers, a and b cannot both be 0. So it can look like this, where you have a by equals c, or you can have an ax equals c, something like this, right? It only has one letter equals a number. That's considered standard form. Okay, the graph of a linear equation in two variables is a straight line. It's just linear. Yes? Okay, so knowing that, is this in standard form?
Yes.
Yeah. It says determine whether each equation is a linear equation of two variables. Okay, here, I know it's not in standard form, but is it linear?
Yes.
It is. So the way you can tell if it's not linear is if it has like the square root of x, if it has something over x, if it has x to like the third power, the second power, the fourth power, to the 1/2 power, anything other than just x, it's not linear. Yes? So this is pretty simple, yes? And it has two variables, therefore it is linear. Now, is this going to be linear?
No.
No, because why?
That's a square root.
You have that y squared. So if we were to solve for y, we'd have to have a square root of x. And that's not linear. And then here,
Yes.
yes, remember it said one of them can be 0, so the y was 0 here, which is why we don't see it. Yes? Pretty simple? Cool. So knowing that, we're going to talk about intercepts. So what do we know about the x-intercept? It's where it touches our x-axis, yes.
Horizontal. Is that right?
The x-axis is horizontal.
Yeah.
Okay, but what is always 0? No.
Why?
Y. So with your x-intercept, y is always 0. So if you wanted to find your x-intercept of an equation that's not y equals, you can literally plug in y equals 0 and solve. So this is my x-intercept of this graph. See right here where it touches the x-axis. Yeah? What do we know about the y-intercept?
And x is always?
X is always 0. So if we wanted to solve, we could plug in, I can't believe where plug is. Plug in x equals 0 and solve. And then again, here's my y-axis, here's my point, and this is my y-intercept. Any questions with that? Okay, so then we talk about our slope. Do y'all remember slope?
Yeah.
Okay, so yes, but to find slope from standard form, so when we're in slope-intercept form, that gives us slope, right? And we will deal with that formula here in a couple days. But right now, we're in standard form, so the way you find slope is opposite of a over b. Because we have the formula ax plus by. So the number opposite of the number in front of x over the number in front of y. Yes? Now, remember, slope is rise over run. If you go up, it's positive. Down, it's negative. If you go right, it's positive. If you go left, it's negative. So if you go down and left, that's a double negative. Two negatives makes a... So that would actually be a positive slope. Any questions? Okay, so let's talk about identifying x and y intercepts. So we know our x-intercept, x-axis is here. What's my x-intercept? Okay, but what if we wrote it as a point? Be -4, 0. The reason I want y'all to get in the habit of writing them as points is because every once in a while on a multiple choice test or TEKS test or whatever, DPM, they'll have the right answer, but they'll have it flipped. Okay, so if I get you in the habit of writing the x-intercept with y second, hopefully that'll help. Okay, now our y-intercept is what? 0, -6. Yes. Okay, so I'm going to take attendance. I want y'all to try the other 4 really fast, and then we'll talk about them. So what's my x-intercept for number 2?
-2,
And?
2, 0.
Perfect. What about my y-intercept?
0, -3.
Okay, somebody else tell me my x-intercept for number 3. Where does it touch on number 3? At 0. So it's 0, 0, which is the exact same place that it touches. I went backwards. On my y-axis. So my y-intercept is also 0, 0. Okay, x-intercept. What's my x-intercept on number 4? It's somebody different. Does it ever touch the x-axis? No, so it's none. And don't put 0, because 0 is a number, and that's telling me you think it touches at the origin. Does that make sense? Unless you put, I don't know, just put none. Okay, what's your y-intercept? Somebody said it. How do I write it as a point? Perfect. So again, x-intercept, what's my x-intercepts here? 5, 0, and -1, 0, perfect. What are my y-intercepts? 0, -2, and 0, +2. Any questions with those? Pretty simple. Okay, now we're going to go into graphing. So really, we need the same information. We need these 3 things when we're graphing: the x-intercept, the y-intercept, and the slope. Because they're in standard form, it doesn't just give us any of that. We have to find it all. So let's start with our x-intercept. Well, with x-intercepts, we know y is always 0, correct? That means I can take my formula and I can plug in y is 0. Yes? Well, plus 0, does that change anything? So I cancel it, and how do I solve now? Huh? Divide. And I get x-intercept is 5 over 2, 5 over 2, 0, which is not a pretty point, so I'm not going to plot it. It's going to come into handy in just a second, though. What's 5 over 2 as a decimal? 2.5. Okay, let's look at our y-intercept now. So y-intercept is where x is always 0. So I'm going to do the exact same thing, except this time I'm going to rewrite it, but instead with x as 0. Well, what's 2 times 0?
0.
So this cancels, and what does that give me?
5.
Y equals 5. So I know my y-intercept is positive 5.
When you do the decimal at the top, it doesn't matter if you do, it doesn't matter that if you put in a fraction or a decimal point?
No, I'm going to show you why I put it in a decimal here in a second. So I can't just plot a graph with one point. I have to have it 2 points or a point and a slope, yes? So let's find our slope. So M stands for slope, and we know that it's opposite of A over B, negative A over B. Well, I'm going to put the negative and I'm going to put the fraction bar. What's my A? Well, let's label A, B, C. What's A?
2.
2. And what's B if there's no number?
0.
No. 1, yes. Now, 2 over 1 does not simplify. I could write it as negative 2, but we want slope to be a fraction. Now, I'm going to rewrite it, and I'm always going to give my negative if it's negative to the top. Sometimes when it's out front, it confuses y'all on which direction to go. So negative 2 goes down, positive 1 goes right. So from here, I'm going to go down 1, 2, right 1, down 1, 2, right 1, down 1, 2, right 1, down 1, 2, right 1. Try to do at least 4 or 5 points if possible. And then y'all's ID badge is your perfect ruler. So here's my question. We said that our x-intercept is 2.5. Did we touch at about 2.5? If my line was perfect?
Yeah.
Yeah. So that's kind of a quick check to check your work. Like, did it come close to the fraction that we got or the decimal that we got for the others? Now, give me a random point of a number of a line that or a point that we plotted. Well, 2 and 1. Okay. So there, now our table is full. Any questions with that? Okay, when you're done copying that, I want you to flip to the back so I know everybody's ready. Okay. So same exact concept. I always start by finding my x-intercept, which is where y equals 0. So I'm going to rewrite this, but instead of y, dang it, I'm going to put 0. Well, what's 3 times 0?
0.
So this cancels. And I'm going to divide both sides by what? Negative 5. And what do I get? So I know that my point is on the x-axis at negative 1. Everybody okay with that? So now let's find our y-intercept. That's where x is always 0. So I'm going to, rewrite it, but this time with x being 0. Well, negative 5 times 0 is 0, and I divide both sides by 3. Does it give me a pretty number? No. And if I had to write it as a decimal, look, it's 1.6 repeating. Okay, so we can't plot that point. So what do we find next? The slope. So I put my negative and I put my fraction line. What is my A value?
Negative 5.
And what's my B value? Now 2 negatives make a positive. So these 2 negatives make it positive. So it becomes positive 5/3. Well, positive 5 goes up, positive 3 goes right. So from that point, I'm going to go up 1, 2, 3, 4, 5, 1, 2, 3. And now I can't do that again, but I can do opposite. Watch, if I go down 5, backwards 3, did that bring me back to my original point? Yes, so I can do it one more time. Down 1, 2, 3, 4, 5. 1, 2, 3. There's my other point. I'll draw my line. Okay, and then again to check our work, did my y-intercept end up being about 1.6? Yes or no? Yeah. So that was a quick check to check our work. And then to fill in a random point, we had the point 2.5. Any questions with those? Okay, so our last two are our special cases. When I look at this, how do I know it's a special case?
Because it has y equals -2 instead of the whole problem.
Yeah, there's no x. So we call this a Hoy problem. So we've talked a little bit about Hoy-Vux. Hoy stands for horizontal. 0 slope. Y equals equation. So that means I'm going to have a horizontal line at y is -2. Well, here's my y-axis, here's y is -2, and it's going to be a horizontal line. Now my equation tells me y is -2. That means everywhere there's a y, it's going to be -2. Does my x matter? No. Look here at -5, my y was -2. Here at 0, my y was -2. And here at 3, my y was -2. Didn't matter where, it always has a y of -2. Yes? It's going to be y is -2. Okay, last one. How do I know this one's a special case? It's just x, there's no y. So we call this Vux vertical undefined slope x equals equation. So I know at x equals -2, well here's x is -2, I'm going to have a vertical line, which is up and down. And I know that everywhere in the table, x is going to be -2. So again, at 5, x is -2, at y is 5. At a height of 0, x was still -2, and at a height of like -2, x was still -2. Didn't matter the height. Okay, you do have a practice. This next page. If you have questions, make sure you're asking.